Hi, folks, and welcome to another episode of Caylent's webcasts on various topics. I'm Brian Tarbox. I'm a principal solutions architect here at Caylent, and I'm pleased to be joined by Chris Gonzalez, who's a platform architect at Caylent. And so we're going to be talking about AgentCore, and we're going to be doing a deep dive. But AgentCore is such a large system, a wonderful system, but quite a large system that we're going to be focusing on a few individual pieces. And just a quick obligatory shout out to our employer, Caylent. We win Partner of the Year quite a bit. We're an AI services competency winner, premier tier services. We've done lots of migrations. We've had over 200 generative AI projects that have gone to production, and it's a cool place. I've been here just about 3 years, and that honeymoon has not stopped. Chris, how long have you been here?
It'll be 4 years for me in August, so July 31st, August 1st.
Oh my God! Wow. Okay, so very very cool. So we're going to talk a little bit about AgentCore. Most of you probably know somewhat about AgentCore, but we're going to do a very quick level set. Don't worry, we're not going to spend too much time on level 100 stuff. Then we're going to talk about runtime, the code interpreter and browser, a little bit on pricing, and then some on quotas. And then Chris is going to give us some really nice demos. So the question I always like to ask is, so for any new service, what problem is it trying to address? And AgentCore is trying to address, and I think very successfully, the undifferentiated heavy lifting that happens anytime you're doing an agentic system. And while Amazon certainly, makes stumbles from time to time, AgentCore, I think, is one of the places where they've done exactly the right thing. They waited a bit to see how people were writing agents, and then they noticed the patterns, and they wrote a system that helped you take care of the things that you had to do every single time you wrote an agent. So it's the ilities, scalability, observability, all those ilities. So basically, that's what AgentCore is there for. AgentCore is made up of a number of components. And this is, of course, evolving. So you will see different components come and I suppose go as well, but probably just mostly more ones get added. And one of the really nice things about AgentCore is that you can use different pieces without having to use other pieces. So you can just use the memory if you want, or you can just use the identity. You can add pieces as you want. So it's a very pluggable kind of system. And as you start using AgentCore, there's kind of a maturity pipeline that you go through where first you get it working, then you add some cool stuff, then you notice some problems, and you refine some things. You very often have neglected to do good observability because we're all humans, we're all pressed for time. And by the same token, oftentimes, although we shouldn't do this, oftentimes we forget about having enough security. But only after you've gone through all those phases can you be actually ready for production. So we have our hypothetical developer who looks a little tired. There's probably been a lot of coffee, but you got it working, and it's kind of cool. And wow, I'm getting something working. And then, hey, I could call some code, and I could do some stuff in the browser, and that's pretty exciting. And it's still fun. And then maybe you discover that your system doesn't have memory, and so it's forgetting things that you asked previously, and that kind of stinks. So you better add some memory to give your user a better experience. And then what is it doing? I mean, this is one of those things where we sort of hate. It's my agent is doing what, and it took how long, and it called how many agents, and so I better add some observability. And then, oh, I've changed some things, and the quality of the answers is different. Maybe I should have some evaluations built in. Okay, now I can see what's going on, and it's not good. because there's all kinds of access things going on. And so, well, maybe I better add identity and policy and a few other things. And then finally, it's ready for production. You have some happiness. Maybe you had time to have another cup of coffee, and things are good. And we very often go through all these phases, but at least when we're going through these phases, AgentCore gives us tools to help for along the way. Now, before we had AgentCore, you had to do all this manual stuff. And Chris, maybe you can comment on how much fun this kind of code is.
Yeah, before Agent Core, we were trying to piece together libraries from all over the ecosystem and or write our own custom Python agents. And now Agent Core gives us a layer in which we can abstract all that and use building blocks that it provides to help simplify at least the user experience side of things.
The code that you write has no bugs in it has been one of my mottos. So the best pull requests I like are the ones where you're actually deleting lines of code. And this isn't trivial code. This is code that you could get wrong. So it's better not to have to write it. So this is another look at the various components of AgentCore, and I'll observe that the developer guide is 1,220 pages. You're looking at two of the very few people who read the whole darn 1,220 pages, and there is a lot there. So we're going to try to help you out by making your journey a little quicker.
Yeah, I mean, before Agent Core, we were trying to piece together stuff in old legacy services that we don't have or we don't use anymore. Specifically, that helped us tie together. You know, Lambda. We had to tie together SQS for queues and messaging and all this sort of stuff, and maybe an EC2 here or there to offload some heavy tasks. And so now Agent Core gives us some of these built-in components that we don't have to worry about underneath. That just kind of works.
Yeah, this looks like our old spaghetti code or spaghetti diagram. It's kind of fun to try to make one of these diagrams. And I will say, once upon a time, I wrote a system that tried to, not, to do one of these diagrams with the least number of cross lines. And the better approach is not to have so many lines and boxes in the first place. But anyway. Um, so how do agents run nowadays? Well, AgentCore basically takes your code and creates a Docker image. It sticks it into ECR, and then it runs it in Firecracker. And we're going to talk a fair bit about Firecracker because Firecracker, again, is one of those sort of amazingly cool things that Amazon has done and done really, really well, in that it gives you all kinds of security. You're using standard Amazon tooling, and you have private VM sandbox, even though we can't seem to spell sandbox. But so there's still room to go. So, but there's also another way. You can do what's called direct code deployment, in that you can basically put your code. You can have AWS put your code into a zip file. It uploads it to S3, and then AgentCore does all the work for you. And this lets you go a lot faster. It's taking care of the underlying service environment for you, and this was actually sort of surprising to me and striking. This approach, which is, I guess, the rapid prototyping path, is so much faster. You can get 1,500 TPM versus 100 TPM for containers, which I guess shows that there is still some overhead for all that container work. But you can do it. You can do it either way. Now, Amazon typically says do the direct code deployment initially for prototyping, and then move to the standard approach. But it's up to you. You can do whatever you like.
Yeah, and our demo that we'll see later is a direct code deployment. So we'll see an example of that.
So a question we get asked a fair bit is, well, isn't this just durable functions? It's like, no, it's similar to durable functions, but it's not quite the same. In durable functions and AgentCore Runtime both use the Firecracker VM under the covers, but there's slightly different coding. You're going through different layers of the Amazon ecosystem. So don't get confused. They're similar, but it's people said, well, aren't they just durable functions under the covers? And that's not actually the case. So just to save yourself some confusion there. one of the important concepts to get with runtime is this whole session-based execution. So when you start an AgentCore runtime, if it doesn't have a session ID, it creates a new session ID and provisions the VM. If you then make additional calls to the system, it'll use that same VM, which means that your cold starts, go away because your VM's already warm. The code stays in resident in memory. Because the container stays alive, you can store variables in memory. So if you have a Python list, you don't have to worry anymore about saving that out to S3 or to Dynamo. With the runtime execution model, it's still there. When you come back to the runtime, it's still running. Now, to do this, we have the ping mechanism. And Chris, do you want to talk about that?
Yeah. So the ping mechanism is under the hood. The Agent Core control plane will call out to your runtime function, where your runtime compute, and expects that it gets a response back from your ping endpoint. So whether you write the code manually, like we'll see in some of the code examples upcoming, or you're using some of the abstractions through the library code that Agent Core can provide you, it expects that ping mechanism, or your function will time out after that 15 minutes is over.
Right. And there are some interesting timeouts. And if you're used to lambdas, remember when lambdas uh, used to run for 5 seconds, 15 seconds, 15 minutes, whatever. These functions can run for 8 hours, and there's 15-minute idle timeout and quite a big maximum payload size. So you can control those, you can tweak those, but you can do much longer running systems. And Chris, maybe this sort of already talked about this, but you can explain this a bit.
Yeah, so this is just a code example of what we discussed in the previous slide with the ping endpoint. And so if you're implementing the interface, the contract the Agent Core expects by hand, in this case with a fast API, you must have an asynchronous non-blocking ping endpoint. That way, Agent Core doesn't terminate your runtime session at the end of the timeout period. It can keep it alive for that that 8 hour period of time. So you must expose that endpoint. Um, like I said, it expects a non-blocking asynchronous endpoint. Okay. And as discussed, the endpoint is just used internally from Agent Core. This is not a public exposed endpoint.
And Chris, because I'm sure people will do it. What happens if I forget to make this an async call?
Yeah, that turns it into blocking, and then your runtime will get terminated.
Yep.
Yep.
So keep that in mind. If your runtime is terminating out from under you for reasons you don't know, go take a look at your ping function.
Yep. Make sure that it is asynchronous, regardless of your runtime language, whether that is Python or TypeScript. Make sure it is asynchronous.
And it might actually be an interesting experiment. Get the system working, and then not in production, then in your own environment, take the async off and see what happens, just so you get exposed to that in case it happens to you for real. Because I'm a big fan of get things working and then break them a little bit, just so you get some learning.
And then secondly, and this is again focusing on if you're just doing custom code, you're not using any of the library abstractions. You also must have you must be able to receive a post request to your invocation to an invocations endpoint with a payload. Okay. And in this particular code example, we're just illustrating that we're sending a payload in. In this case, we're just doing a quick async IO sleep call that just simulates some processing. Okay. And then we return our response. So whether that response is going to another external system or some other downstream processing, the fact of the matter is you still need to expose an invocations endpoint.
So, a question a lot of people asked, and I asked when I was starting with this, is okay, how do I control the size of the agent? Because, with EC2s, you control the instance type. With Lambdas, you control the memory and thus indirectly the vCPU. But how do I do it with agent runtimes? And the short answer is you don't. Um, uh, Basically, we're trying to take away the whole sizing game for you. Now, there will be some auto scaling, but to a limit. It'll scale all the way up to 2 vCPUs and 8 GB of memory, which isn't much. It's like, whoa, but what if I'm doing more work? I mean, that doesn't let me do hardly anything. And this requires a mindset change in that you don't run a monolithic agent inside Agent Core where the agent itself is doing the heavy computation. What the better approach is to offload that to a tool, batch or Lambda, where you do have control over the size of your computation unit. And the agent core, the agent running with Agent Core is just essentially the manager. So if you find yourself wishing you had a much beefier instance, go back to the slide because you may be thinking about the thing wrong.
So now what if we want to invoke our agent core runtime from, say, another service? Let's say we have maybe an API that's living in ECS Fargate or ECS on EC2, and we want to send part of our workload to the agent for processing, whether that be code interpreter or something like that. Well, we can just do that with Boto 3 or any of the SDKs available. So in this example, we're just using Boto 3. We're creating an agent core client. We're creating manually the session ID. That's an important concept when we talk about agent core memory. If you want to save that the session data to be referred back to later, you need to have a session ID so that memory can be retrieved. And then simply we're passing in the payload. We're dumping out this payload. Actually, we're just encoding the payload, and then we're passing it to the runtime through the invoke agent runtime call.
So very, very straightforward. And so these are the things you can configure about the agent. And the timeouts are really interesting because you only get charged for the compute time. And you may have seen earlier that the ping calls always returned 200. And this is something that surprises a lot of people in that it's like, hey, when I'm done, shouldn't I return something other than a 200? And it's like, no, that will terminate, but it looks like a crash rather than a termination. So you can explicitly terminate the session, or you can just wait for it to time out. And so this is basically saying if you're doing something interactive, your timeouts should be fair. Can be a bit longer. If you're doing demo things, keep them shorter so you're not wasting VMs. But again, you need to understand what your workload is and what its requirements are so that you can properly set these timeouts.
So this is an example of using the Bedrock Agent Core library package, specifically the Python package. In our previous code examples, we were looking at what we have to do. What do we have to do to satisfy the runtime contract that Agent Core expects? When we're using the library, it handles that stuff for us. So the ping endpoint is handled under the hood by the library. The invocations endpoint is handled underneath the covers through the library. And all we have to do in our code, you can see towards the bottom, we have a main function. We just need to decorate that function with app.entryPoint, and then everything runs for us. In this case, it's running in agent, but it could be any other agent framework that you use, Python or TypeScript. As long as you decorate that with the app.entry point from this specific Python package, you're good to go.
And that actually brings up a point that we probably should have mentioned earlier, in that Agent Core is fairly agnostic about the framework that you're using, which is really quite nice. Um, so we're talking about tools and how we run tools, and tools run in a Firecracker VM, and the link on the bottom right is goes to the design of Firecracker. And if you're at all interested in learning a little bit more under the covers, that's actually a quite good place to start reading. And so when you run a tool, there's a strict one invocation, one micro VM strategy. You invoke the code interpreter, it does its thing in the micro VM, it returns the result, and then the micro VM is destroyed. And so there's absolutely no sharing. There's no possibility of contamination between invocations or between sessions. There's no files left around. All of that is handled for you. And this is basically how they run the interpreter. You have your agent, you have your large language model. It calls the code interpreter session. It can do some telemetry out to your observability. And so you can basically have your agent execute code. Um, we know that there are things that LLMs are not great at, like doing math, for example, although that's changing. Of course, everything in this is changing. Um, so you can basically have your agents do code. So it's your escape valve to do something that maybe you hadn't planned for.
Yep. So another code example, this time we're actually using Strands and specifically the Strands tools to use its code interpreter package library that we can import the AgentCore code interpreter from. So we mentioned at the start of the session that you can use everything in AgentCore or you can just use bits and pieces. So we can extract out memory. If we want to use memory, we can, in this case, do code interpreter. So simply, this is just establishing a code interpreter instance and invocation in US West 2. Okay, we're giving the agent some instructions. In this case, we want it to make sure it writes some Python code to verify calculations and algorithms. In this case, I want it to make sure it does test first because we should just be testing first all the time. And we're just asking it to calculate the first 10 Fibonacci numbers. But more important than that is just how we're using the abstraction as another route into Agent Core.
Right. And so we're not actually writing the code. We've asked the system to write the code for us, which is pretty cool. You can also, though, just actually supply the actual code. Um, and it's just a different model. The security, when I put on my security hat, I kind of like this approach because it's more deterministic. But this is a whole one of our design pressures between determinism and indeterminism, and how much do we let the system decide what to do, and how much do we put guardrails on it. But so you can write the code, or you can have the LLM write the code. If you have the LLM write the code, pay particular care to the instructions you're giving it. And then this is uh, yet another way of doing it. Chris, you want to grab this one?
Yeah, this is just doing raw Bodo 3. So this is probably like the most user involved way of doing it and probably the most lines of code that you have to write. Specifically, this approach it requires more explicit session management. So you have to basically call start code interpreter session and also call stop code interpreter session when you're done.
Right. So you have lots of choices. Um, if you like writing code, you can write more code, or you can write less code, or you can let.
It also just depends on the needs of your system. And our first example, we were using Fast API. I know that's a very popular API framework in the Python ecosystem specifically. So Agent Core provides you a way through its library extensions and also through Strands package built-ins that you can adjust it to your current developer experience and your current team workflow.
Yep. Excellent. Excellent. Um, So Code Interpreter has all kinds of security. There's infrastructure because we get our sandboxes. We have network protection by default. There's no external egress, so you can't exfiltrate the data. You can't have an agent say, "Oh, grab me everyone's social security numbers and pull them out," because it can't pull them out. You can have Bedrock guardrails, which you should be doing anyway. Operational resource quotas, so you can protect against denial by wallet attacks. And then, of course, you should be doing IAM and CloudTrail. I mean, but most of these are just table stakes. But it's important to say agents are wonderful, Agent Core is wonderful, but there's still the shared responsibility model, and you still have a point, things that you have to do. Um, and this is an example of actually calling the code interpreter. And you'll see there's network mode, public, sandbox, or VPC. Um, uh, you can open up your code interpreter to have public networking. Um, uh, I'm never going to approve this in a code review.
Yes, or a compliance or security review for that matter.
Right, right. But you can do it, and there might be reasons. But if you're going to do this, the burden of proof is absolutely on you to explain why this is required in your case. So, um,
One thing, Brian, if you'd go back to that last slide, there's also the VPC networking mode. So we can hook this into VPC resources. So if we have databases or something and we want secure compute where we can do we have an agent that does database operations, read operations, or maybe some operations behind the scenes, migrations and stuff like that that have been tested appropriately and have gotten through the proper controls from a development standpoint that it's ready for production. You can unlock a lot of stuff by giving it VPC networking.
absolutely. And that is a great segue to the notion of unlocking. So the code interpreter comes preloaded with all of these packages. And these packages do not count against your quota or your size limitations. These are just built in. I mean, this is a very wide range of things that come preloaded that you can just call. So it's a the first time I scrolled this list, I was like, okay, that's some lists. There's some packages. There's some more packages. Oh my God, how many pages of packages am I going to walk through? So, um, so now we move over to Gateway, and so part of one of the rationales for Gateway is to find tools, and it's designed to discover and connect to tools at scale. And the at scale is important. Um, if you have lots and lots of tools and lots of agents, then Gateway can be very handy for finding them. But if you have a smaller system, or dare I say, a more well-defined system, you can get away without using Gateway. We recently internally at Caylent had a technical discussion about one of our projects, and the question was, "Huh, Gateway? Did we need to use this?" And I was like, yes, but it's not always required. Gateway has some wonderful features, but it also adds some complexity, of course. Um, and as with everything with LLMs and agents and AI these days, best practice is still something we're working out. Depends on when you watch this. By the time you watch this, maybe there'll be a whole another set of best practices. So watch this soon. AgentCore Gateway has all kinds of capabilities. There are security gateways to help you use OAuth. There's translation utilities so that you can use Model Context Protocol to call your tools directly or compose tools into groups. You can do credential exchange. There's the infrastructure manager, and then to me the really interesting one is the semantic tool selection, where you can use the LLM to figure out what tool um, you should actually use. So again, putting my security hat on, I have to wonder whether it's a good idea. If you have so many tools that you have to use semantic search to figure out what tool to use, to me, that's a code smell. And it means that you better have descriptions of your various tools that are distinct enough that the semantic search can really find them. Because find the prescriptions I want versus find the prescriptions I have versus find my neighbor's prescriptions, you want to be clear. So um, it's just like the old days of microservices. How many microservices do you have? And now we get into AgentCore Policy, where we're going to have the demo. Um, so um, as we've been talking about, there can be security concerns to doing all this, and policy lets you create security controls that protect what the system can and can't do, and that gives you deterministic enforcement, fine-grained controls, and you can implement organizational-wide consistency using Amazon's Cedar policy language. And now Chris is going to give us a demo.
Okay, so as Brian said, we're doing an Agent Core Policy demo. So let's talk about the policy first. So this is attached to an Agent Core Gateway and specifically a policy gateway. And we're going to be demonstrating how you can have, say, an automated refund agent, but also set controls on how much money that agent can refund, until there needs to be some sort of human interaction or an escalation. So in this case, we're going to allow refunds under $1,000, and we enforce that through our Cedar policy. Basically, we're saying for this principle, the action of a refund target, and in this action, I've defined it as process refund, um, being called by our gateway that we have, we are going to basically deny this when, I'm sorry, let this go through. We'll allow this to go through to the back end side of the gateway when the input amount that we're wanting to refund is less than $1,000. So I've set up just a little demo here where we can have a chat, and we can basically do our normal agent interactions, and we'll try to do a refund for below $1,000 and above $1,000 and see what happens. So I'm just going to interact with this agent. Hello, I would like to make a refund. And this is sending back to AgentCore Runtime, and we should get a response here. We need to provide an order ID and a refund amount. So let's do that. My order ID is 12345, and my refund amount is $800. That's a big refund, but we'll go with it. And this, because it goes underneath our policy threshold, and the gateway is an MCP server, it basically allows the tool call that basically routes to the backend Lambda function that handles the returns. Okay. Now, if I try to do this again with the same order and for over $1,000, I should get a denial. And what it is under the hood is just it denies the tool call and the MCP server. So if you want to have strict controls, policy controls over which tools your agent could call, then AgentCore Policy is a great way to do that. So let's try to do this for $2,000. Please refund $2,000 for order 12345. And it should deny us and say, nope, we've got to escalate this. Sorry, we can't refund you that. You can contact our management team, review your original order, provide additional details. So just a simple use case of how we can enforce some MCP tool call controls specifically. I will note that AgentCore Policy is still in preview as of time of this recording in February of 2026.
Now, besides policy, there's also gateway interceptors. And so you can basically call a Lambda on the way in and on the way out. And and these are for very different sorts of things. These are for massaging the data coming in or out, or actually providing different kinds of features. So suppose your organization wanted to say, hey, I've got customers who are doing nothing but refunds. And even if the refunds are under the $1,000 threshold, if they're doing lots and lots of refunds, maybe that's a problem. So you could imagine a Lambda interceptor that looked up the customer ID and figured out how many refunds that they had asked for in the last, day, week, month, whatever. And if it, if they were doing too many, denied it. So I like that Amazon almost always gives us a way to escape out to Lambda to do whatever we need, whenever we need.
Yeah, Brian, and because it's just Lambda, we can also just fire off requests to other services, whether it be monitoring or alerting, fraud, that sort of stuff. So especially in the realm of financial services, very important use case here.
Right. Absolutely. Absolutely. And so this basically just covers what we said. Are you trying to do governance? That's for policy. Are you trying to do integration? That's for interceptors. For policy, you've got Cedar. For gateways, you've got Lambda, so you can do anything you want. Ease of use, it's like Cedar's very, very easy. And I don't know if I'd say interceptors are moderate. I mean, come on, it's 2026. We all know how to write lambdas now. The policy basically is block or allow, whereas the Lambda can do anything. And And there we go. So two related but very distinct features. But here's the caveat. Policies only control interactions when you're going between the hops. So in Chris's example, we had a system that determined the refund amount, returned the refund amount to a system, to another tool or agent that actually did the refund. If his agent both determined the amount and actually did the refund, then Gateway wouldn't have a chance to intercept and stopped it. So you have to pay attention to that sort of thing. So we're back to shared responsibility. It's still a thing. Even with AgentCore, you can still write insecure code, and so you should still have all the standard reviews of it. Now pricing is interesting because it's all going to change. By the time you're watching this, all these numbers will be different. So we're not going to go in a lot of detail here because it will be different. But it's here as reference. But just understand some concepts that AgentCore runtime and browser and code is based on actual usage. The wait time is free. Gateway has its own pricing. Identity has its own pricing. Memory, which we haven't really talked about, has its own pricing. Your foundation model costs, of course, are separate. ECR storage is pretty inexpensive, but you do have to pay for that. And then there's all the network data transfer. So it's tricky to figure out, and we can't give you exact numbers here. But when you're actually just understand the dimensions where costing happens. And these are some sample numbers. The numbers are quite small. I mean, code interpreter, 0.08 of a cent per gigabyte hour. Policy is free right now, as Chris said. It's in preview. It will have a cost. That's undoubtedly something that's going to change over time.
Yeah, for that one, it uses Amazon verified permissions under the hood. So I would imagine that it will be some sort of API based pricing, like a lot of this is.
Right. Quotas. There are lots of quotas involved because AgentCore can do all kinds of things. Lots of these are adjustable. Some of them aren't. So pay attention to this. The your response time from Amazon and getting a quota increase, that's out of our control. It can vary, but all of these things are adjustable. If you know that you're going to hit some of these limits, we'd suggest that you make the quota request sooner. Don't wait till the last minute to do them. We've also know that if a small quota increase is more likely to get automatically approved. If you say, I want 100x my standard quota, that's going to require a human, and which can take longer. More quotas that you can hit, or quotas and thresholds. And that's it. So we've covered just a few pieces of AgentCore, but we wanted to go into some depth on those, especially the ones that, at least from our point of view, constitute the security aspects. Because executing code from an agent makes the hair on the back of some of our necks stand up if we've done security. So it's good to see that there are ways to protect yourself for that. Chris, any last comments?
No, I think the security is just a huge part of this. I mean, considering all things considering, we're still responsible for that. We're still responsible for right sizing our workloads. We're still responsible for well architecting all of our workloads. Proper IAM policies on any downstream tools that your agents are calling. So all of those fundamentals that we know and love about security still apply regardless. AgentCore just abstracts another layer on top to simplify running these agentic systems in the cloud.
Yep. So thank you. If you stay tuned for other episodes we have, and go Caylent. Have a good day.
Bye.